Okay, we're on to section 3.6, which is on special factors. This is it. You're going to learn the last type of factoring today. I hope you're like me and you've learned to love it. So basically what we've done is greatest common factor. Remember removing the greatest common factor? We did that type of factoring. We did simple trinomial factoring. We did Bobby Bridge. And now we really have one last type. And that last type is called difference of squares down here. But before we do that, we'll do perfect square polynomials. And what you'll see is we've actually already done this. There's not really anything new to learn here. So let's go at it here. When you first look at this, what type of factoring does it look like? I hope you agree with me. It looks a lot like simple trinomial. You have an x squared and then an x and then a constant here. So we want to try to take out a greatest common factor. We always try to do that, but there is no greatest common factor here. But since it's simple trinomial, we can just go straight to bracket, 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 bracket. And what are we looking for here? We're looking for two numbers that multiply to 36 and add, remember this sign will tell you, add to positive 12. Multiply to 36, well there's quite a few of those. There's 1 and 36 and 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And we want two numbers that multiply to 36 and add to 12. So which of those pairs add to 12? This one. So there's our numbers, 6 and 6. First of all, since it's x squared, we put x and x. Put our numbers in, put the big one here. Well, they're both the same. So just put 6 in one and 6 in the other. Drag down that first sign, so it's a positive. Now, positive times a what equals that positive? A positive times a positive. So what's different about this, or what's special about this? Well, what's special, and we have talked about this before, you have x plus 6 times the exact same amount, x plus 6. So what does that equal? If you write this as simply as possible, you would write x plus 6 squared. And this is why it's called a perfect square polynomial, because this polynomial, this trinomial right here, x squared plus 12x plus 36, that's a perfect square. There is an amount that you can multiply by itself to get this polynomial. What is that thing you multiply by itself? X plus 6. Alright, so this should happen in all these four here. You're going to get the same amount and it's going to just be squared. It's going to be one factor squared. Alright, let's do another one here. So what are we doing here? We're trying to take out a greatest common factor, but we can't. And we have this 9 out front. So what does that mean we're doing here? We are doing Bobby Bridge. So we're looking for two numbers that multiply to 9 times 25. My goodness, what's that equal? It equals 225. Break the calculators out if you're not sure about that, but it is. 225, I don't want to make this list. This is going to be terrible. 1 times 225. Can't divide it by 2. You can divide it by 3. I know because when I add up the digits I get 9, so you can definitely divide it by 3. It's 3 times 75. 4, no. 6, no. 7, no. 8, no. 9, yes. 9 times 25. 10, no. 11, no. 12, no. 13, 14, 15. Last one's 15 times 15. Okay, we're looking for a pair of numbers that add to 30. Well, here they are. Hey, surprise, surprise. It's the same number, 15 and 15. So we rewrite the first term, 9x squared. We have to decompose. Remember in Bobby Bridge, this is Bobby Bridge here. We have to decompose this middle term. So these are the numbers we're going to use, 15 and 15. To get negative 30x, we have to do minus 15x. Take away another 15x, and then rewrite the plus 25. Next step in Bobby Bridge, pair them up. Okay, the greatest common factor of the first two is 3x. And what do you multiply 3x by to get 9x squared? 3x. What do you multiply 3x by to get negative 15x? Minus 5. There's a minus sign, write that down. 15x and 25, the greatest common factor is 5. Multiply that by 3x, and negative 5 times negative 5 equals 25. Okay, we got the same in each bracket, so we can pull that out, 3x minus 5. And what's left to put together? The 3x minus 5. Look at that, 3x minus 5, 3x minus 5. Final answer, 3x minus 5 squared. Alright, next one. Before you start doing a bridge here for Bobby Bridge, what should you always do first? Look to see if there's a greatest common factor. And there is a greatest common factor in this question. The greatest common factor is 5. So we'll take out 5. Leaves us with 4x squared minus 4xy plus y squared. Okay, what do you notice now? Well, what I notice is we have a y here and a y squared here. So this is one of those ones where the y is going to kind of pop in at the end of each factor. Kind of takes care of itself with the Bobby Bridge. It's more the simple trinomials that is a little trickier with that extra letter. This is definitely Bobby Bridge because we have the 4 out front. That can't be factored out. So we're looking for two numbers that multiply to 4 times 1, right? There's a 1 there. So we want two numbers that multiply to 4. Well, there's not many choices. 1 and 4 and 2 and 2. They have to add to 4 as well. 2 and 2. So we can decompose the middle term. So we rewrite the 4x squared. We want to decompose the negative 4xy. Negative 4xy, don't forget the y. So it should be take away 2xy and take away another 2xy. Then rewrite the plus y squared. Okay, pair them up. We have a greatest common factor up front, so we'll drag that down and let's put a square bracket here. Greatest common factor of the first two terms is 2x. What do you multiply 2x by to get 4x squared? 2x. What do you multiply 2x by to get negative 2xy? Negative y. There's a negative sign, I'll write that down. Greatest common factor of 2xy and y squared is y. Multiply y by 2x to get 2xy, and multiply negative y times negative y to get the y squared. Okay, we should get the same in each bracket, and we did. So we have the 5, which is the greatest common factor we pulled out. We have the 2x minus y, and then we put these two together, and you get another 2x minus y. What do you know? It's another perfect square polynomial, so it's 5 times 2x minus y squared. Notice that doesn't mean the 5 squared, just the 2x minus y squared. So this is your final answer. Last one, look for a greatest common factor. I don't see, oh, there's a greatest common factor here. What is it? I can take an m out of each one of these, and I can also take an n out of each one of these. So mn is our greatest common factor. What's left? 9m squared plus 12m plus 4. Okay, it's Bobby Bridge because of the 9. Probably don't need to do this. Isn't this a bit repetitive? So we're looking for two numbers that multiply to 36. I already have 36 written up here. I don't want to write it again. So multiply 36 and add to 12. What do you know? It's 6 and 6 again. So I can go straight to that. Greatest common factor is mn, 9m squared. Now I'm going to decompose the 12m. So I get plus 6m plus another 6m plus 4. Pair them up. I'm doing this really fast. mn, whoops, n, square bracket. Greatest common factor of the first two is 3m. Leaves you with 3m plus 2 plus. Greatest common factor of these is 2. Leaves you with 3m plus 2. Should get the same in each bracket. You did. So you have an mn out front, then this 3m plus 2, and then in the other bracket another 3m plus 2. It worked. So we have mn as our greatest common factor. We pulled out right at the start, and then the 3m plus 2 all squared. We didn't really do much different there than we did before. It's just a matter of putting that squared at the end. If you end up with the same factor twice, you just put it with the squared. Alright, now for something definitely different. This is the last type of factoring. It's called difference of squares. So to teach you this, let's take a look here. The question is x squared minus 25. It's only a binomial. We could turn this into a simple trinomial though. What's missing to make this a simple trinomial? We're missing an x term, right? Usually with a simple trinomial it goes x squared and then an x and then a constant. We have the x squared, we have the constant. So what could we add in? How many x's could we put in here to keep it exactly the same? Well, how many x's do you see here? I see none. So if I put x squared plus no x's, 0x, and then take away 25, it's really just the same thing, isn't it? Why would we do that? Because now we could answer this with simple trinomial. We'd be looking for two numbers that multiply to 25 and subtract, right? Subtract because of this sign right here, subtract to 0. Okay, what do you know about two numbers that subtract to 0? Has to be the same number. So 25, we want two numbers that multiply 25. 1 and 25 and 5 and 5. Which of those pairs subtract to 0? Right there. So let's do this. We can do bracket, 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 bracket. Since it's x squared, it's x and x. Our numbers are 5 and 5. Drag down the first sign, plus. Now, what's the second sign? A positive times a what equals a negative? A positive times a negative. We're done. Now that was pretty good, but I'd love it if we didn't have to do this middle step. How about if we could go straight from the original question up here down to the answer? So we're going to do one more the same way, and I'm hoping we can see how you could do that. Just skip that step. But for now, we'll do it the same way. It's 4x squared. How many x's do we have? None. Let's put down that plus 0x, or you can put minus 0x. Actually, let's do this that way this time. Let's put minus 0x. Since subtracting no x's makes no difference, it really doesn't matter where you put plus 0x or minus 0x. So we'll put minus 0x this time. And we still have the minus 9. So what we've done is we've turned our binomial into a trinomial. Now, what kind of trinomial is it? Bobby Bridge, you can't factor out the 4. So we're looking for two numbers that multiply to 36, again 36, and subtract to 0. So let's go up to our 36 list again. Which one of these pairs subtract to 0? The bottom one, 6 and 6. So we're going to decompose the middle one. 4x squared. We want to end up with take away 0x, or basically no x's. So you're going to do minus 6x and plus 6x, or you can do plus 6x and minus 6x. Either way, you end up with no x's, and that's what we wanted. Minus 9. Okay, pair those up. The first two, you end up with the greatest common factor of 2x, and what's left is 2x minus 3. And then we have a plus sign. Greatest common factor of 6x and negative 9 is 3, and you end up with 2x. Now be careful here. 3 times 2x is 6x, good, and 3 times what equals negative 9? 3 times negative 3. So we have the same thing in both brackets, 2x minus 3, but what we put together here is 2x plus 3. This is your answer. Okay, again, wouldn't it be great if we didn't have to do all those steps? If we could go straight from the original question right down to this answer? It turns out you can. Are you able to see how you do it? Well, if you take a look at this original question here, you see how it was x squared here? What you're looking for is something that multiplies by itself to get x squared. X and x gives you x squared. And then for the number out here, you're looking for something that multiplies by itself to get 25. 5 and 5 gives 25. As for the signs, make one positive, make one negative. Doesn't matter the order though. Makes no difference which one comes first. Let's try this one and see if it works as well. What's something that multiplies by itself to give 4x squared? 2x and 2x. What's something that multiplies by itself to get 9? 3 and 3. Make one of them minus and one of them plus. You can do it in a different order if you want. You see, all this stuff in between here is unnecessary. If you recognize it's a difference of squares, you can just go right to the answer. Here's how we can kind of put how to do this. If you have something like a squared minus b squared, the answer is just going to be a minus b, or a plus b if you want, and then a plus b. One has to be minus, one has to be plus. Here's the only cases you can do that though. This difference of squares. What does difference mean? Difference means subtract. Squares, they must both be perfect squares. So basically for this to be possible, you need to have a binomial. Just two terms. This never worked for three terms. It has to be a two terms. Binomial. That's how come these ones are easy to spot. They're binomials. Both terms have to be perfect squares. And both of the terms must be subtracted. If this was 4x squared plus 9, you would not be able to factor this. Okay, so if you have a binomial that meets those three criteria there, you can use difference of squares, and you don't have to do all these other steps. You can just go right to the answer. So let's try one. Now, the first one here, I've kind of thrown a little wrench at you, because the first thing you should do always is to look for what? Greatest common factor. What's the greatest common factor here? 25. So we're going to take out the 25, and what's left is x squared minus 4a squared. Great. Now, if we look at the part just in brackets here, let's see if that meets our criteria. Is that a binomial? Yeah, there's only two terms. Is it take away? There's a subtract sign. Yep, there's a subtract sign. Can you take the square root of x squared? In other words, is there something that multiplies by itself to get x squared? Absolutely, x and x. Is there something that multiplies by itself to give 4a squared? Absolutely, 2a and 2a. So this is going to work. So we drag down the greatest common factor, put our bracket, 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 bracket. Something that multiplies by itself to get x squared is x and x. Something that multiplies by itself to give 4a squared is 2a and 2a. Make one of them plus, make one of them minus, and you are done. Now, some of you might have noticed, you might have said, well, what if I didn't take out the greatest common factor? because you could also do this as a difference of square without taking out the greatest common factor. In fact, many people do this. They get so excited when they see it's possible here that they don't take out the greatest common factor. I want to show you the danger of that. If you went straight to thinking, hey, this is a binomial, there's a takeaway sign, and both of these are perfect squares, because they are, here's the answer you'd get. What multiplies by itself to get 25x squared? 5x and 5x. Those multiplied together give 25x squared. What multiplies by itself to give 100a squared? 10a and 10a. Make one of them plus and one of them minus, and we're finished. Or are we? Why did we not get the same answer? Because if you look at this first bracket here, there's something you can factor out of. There's a greatest common factor. And same if you look at this one, there's a greatest common factor. So if you were to make this mistake and you wanted to correct it, what you'd have to do is this. Greatest common factor here is 5, and what's left is x plus 2a, sorry. The greatest common factor of this one's also 5, and what's left is x minus 2a. Since order doesn't matter when we multiply, you could multiply this 5 up front by this 5 here to get 25, and you'd still be left with the x plus 2a, x minus 2a. Believe me, most people will do that wrong. They'll just stop right here, and they'll get the incomplete answer. This is why you always want to look for the greatest common factor first. So this is not such a good method to use here. This is a great method to use there. Okay, next one. Ready? Is it x minus 7, x plus 7? Done? Right? X times x is x squared, 7 times 7 is 49. Let's move on. No, this is wrong. Why? This is wrong because of that plus sign. Remember, it has to be a difference of squares. This is a sum of squares. You cannot factor this. Can't factor. Yes, it's a binomial, and yes, this is a perfect square, and this is a perfect square, but if it's a plus in between, you can't factor. Okay, next one. It's a binomial. This is a perfect square. This is also a perfect square, and there's a minus sign. We can factor this. What do we multiply by itself to get 1? 1 and 1. What do you multiply by itself to get 121, a squared, b 8? Well, square root of 121 is 11. Square root of a squared is a, right? A times a is a squared. What's the square root of b to the 8th? B to the 4th. Why is that? Why is it b to the 4th? Because remember, when you multiply b to the 4th times b to the 4th, what do you do to the exponents? You add them. So you get b to the 8th. This is always the case. If you have a variable to a certain exponent, you just take half of the exponent when you take the square root of it. Make one of them plus, one of them minus, and you're done. Hope you can read that. That's 1 plus 11ab to the 4th power, and 1 take away 11ab to the 4th power. Next one. This looks like an easy one. Definitely got perfect squares, definitely a minus, definitely a binomial. This should be fast. Do you know it's a trick just from my tone of voice? What multiplies by itself to get x to the 4th? X squared, right? X squared times x squared equals x to the 4th. What multiplies by itself to get 16? 4 and 4. Make one of them plus, make one of them minus. Finished? Careful. Do you see anything here? Look very carefully at this. See what you can notice there? We have a binomial with a minus sign in between it, and they're both perfect squares. Guess what you can do here? You can do the same thing over again. What multiplies by itself to get x squared? X and x. What multiplies by itself to get 4? 2 and 2. Make one plus, make one minus. Do we do that same thing again here? No, although lots of people always do that. Why can we not factor this? Because of that plus sign. It must be a minus sign. So what do you do with this? You just drag it along for the ride. X squared plus 4. That is completely factored. This always comes up, a question like this, where you have to use difference of squares factoring and then do another difference of squares factoring. Guaranteed it'll be on your test or something. Okay, I'll leave you with two very difficult ones again. Again, we're kind of looking at grade 11 stuff here, but you can do it. So what you have here is x plus 3 squared minus 81y squared. Do you see that you have really a difference of squares here? If you look at this amount right here as one term, kind of, you have an a squared minus a b squared. So this will work. So how do we do this? Well, what do you multiply by itself to get x plus 3 squared? You multiply x plus 3, and what you multiply that by is another x plus 3. Right? Now, what do you multiply by itself to get 81y squared? You multiply 9y times another 9y. Make one of them plus, make one of them minus. Might need to watch that one again. Basically what I'm showing you is this x plus 3 squared, it's kind of like this is a. And so if it's a squared, you would have one a here and one a here. But instead of writing a, we write what a really is, and a is x plus 3. So you'd have 1x plus 3 here and 1x plus 3 there. We're done. I'm happy with this. I'd give you full marks. It might be nice if you put them in order. Put the x first, then the y, and then the constant. And same over here, the x, then the negative 9y, and then the constant. That's great. But I'd give you a mark for this too. Like, you wouldn't lose marks if you just stopped here. Last one. Well, this isn't something like we got this big trinomial here that's not squared or anything. So what do? Guess what? This is the summation of both things we've done today. Because guess what you can do with this first bit in brackets here? You can factor that, and it's going to be a perfect square polynomial. So let's try that. This is a simple trinomial in the bracket. So I'm just looking here. That's a simple trinomial. So what I'm looking for is two numbers that multiply to 16. 1 and 16, 2 and 8, 4 and 4, and they have to add to 8. Well, that's these ones right here. So, since it's x squared, I have x and x. The two numbers are 4 and 4. Drag down the first sign. A negative times a what equals a positive? A negative times a negative. Hey, look at that. X minus 4 times another x minus 4. So you have x minus 4 squared. That's all the highlighted part. But don't forget, you also have this minus 36 here and this minus 36 here. We haven't done anything with that yet. Well, now look what you're left with. You're left with a question that's just like this. You have this first bit squared, so that's a perfect square, and you have 36, which is also a perfect square. So let's factor this. What multiplies by itself to get x minus 4 squared? It must be x minus 4 times x minus 4. What multiplies by itself to get 36? 6 and 6. Make one of them positive, make one of them negative. Now here's the especially cool thing about this. Look what you can do. X take away 4 plus 6. You can combine these two terms here. So what do you get when you do that? You get x plus 2. Same here, you can combine these two terms. You get negative 4 take away 6. That's x take away 10. This is your answer. Hey, just for fun, let's check this. Remember, you can always check your answers. Pick a value for x. Make it something easy. I'll use x equals 2. If I use x equals 2 and I plug it in here and here, let's see what I get. I would get 2 squared minus 8 times 2 plus 16 minus 36. 2 squared is 4 minus 8 times 2 is 16 plus 16 minus 36. Okay, that's negative 12. Plus 16 is 4, take away 36 is negative 32. Now, if we factored it when we got all the way down to here, it should work when we put that same number, that 2 in there. We should also get negative 32. So let's try. I put 2 in here and here. So in the first bracket, I have 2 plus 2. In the second bracket, I have 2 minus 10. 2 plus 2 is 4. 2 take away 10 is negative 8. 4 times negative 8 is negative 32. Exactly the same number we got there. This answer is correct. Love that. This is a much simpler way of dealing with this mess here. Okay, we are finished. And that's it for factoring. If you still follow all this, you are now a master of factoring. You're going to find grade 11. Much of it will be no problem with you because you do so much factoring. Congratulations.